Hello and welcome everyone to CAC Core Concepts in the series of computer networks. In this video, I am going to discuss about a very important reference model in computer networks that is called as the OSI model. Now, why do we require an OSI, a standardization, first of all? Let's say we have multiple networks and we want to connect from one to another, right? So one network to another network. Now let us say you have to follow some rules. Now the rules here where I am staying locally, they are some rules, and to the network where I want to connect to is in different country and they have different set of rules, right? So when I want to connect to that network, then there will be a conflict, right? So I will not be able to connect to them. So in this case, we require a standardization that is approved by some standard organization. So from wherever part of the world you are using, the same rule applies to all, right? So basically it is a conceptual model which is created by the organization that is ISO, International Organization for Standardization. They help in enabling the diverse communication system. There are various types of communication system and they communicate with each other using some standard protocols. So we have some standard protocols, okay, using which we can communicate. So they have standards with which we can communicate, and this model is called as the ISO OSI, that is Open System Interconnection Reference Model, because it deals with open system. Now, what do we mean by the term open system here is the systems which are ready to communicate with other systems. They are called as open networks. Open closed network is what? They do not communicate with the other networks, right? They are closed. And open system interconnection means those networks which are ready to communicate with the other networks, right? Right. So based on the concept of splitting a communication into 7 abstract layers. So whatever communication you are doing, we are going to break them up into 7 layers where one is stacked onto the other. So this is how your OSI model looks like. You start with the physical layer, data link layer, network layer, transport, session, presentation, and application. So let us get started by understanding in brief each of these layers, and if you keep an eye on my series, each layer will be covered in detail in the entire series. The protocols will be discussed. So here in this video, I am going to briefly discuss about the layers. So when we start with the application layer, this is the only layer which interacts with the user. So when I need to write a mail or something, so I am using some standard protocol. So there are various common protocols that are used by the users. Let's say, for example, if you want to open any web page, so we write the URL as http www something.com, right? So that http is a application layer protocol, and HTTP stands for Hypertext Transfer Protocol. Similarly, if I want to transfer a file, I will go with the FTP protocol. If I want to send a mail, I will go with SMTP, that is Simple Mail Transfer Protocol, right? So this is how you request some content from the layer, okay, and you return some content in the required format. Then comes your presentation layer. So whatever mail or something which you have written, okay, then the data goes to the presentation layer. Now when two networks want to communicate with each other, so you have to perform some activities. That is, you have to maintain some standard rule, right? So this layer is responsible for translation, encryption, and compression. Encryption and compression is important because encrypted data has to flow, otherwise anybody, eavesdroppers, might read your data. Secondly, if your data is too large, especially the media files which are very large, it requires a lot of bandwidth, right? So in that case, it is a better practice to compress those files and send it, right? So this work is done in the presentation layer. So it is concerned with the syntax and the semantics of the information transmitted. So you are going to add on the sender's end what type of encryption algorithm you have used, okay, decoding at the receiver's end, so that they can decrypt and read the data. Compressing will help to improve the speed and efficiency. Then comes your session layer. Session is what? That the moment you start communicating till you close, that is called as one session. So that time between the communication is open, that time is called as the session, right? So when you want to connect to a network, you have to establish a session between them. So it is this layer is responsible for opening and closing the communication. So sessions have different, like dialogue control. You have to keep a track, like it's time to transmit. First, the client asks for a page from the server. The server responds with the page. Then the client asks for some data. So this dialogue control is being maintained. Token management. When let's say you are doing some operation, when you have multiple nodes in the network and you are transferring some data, right? Now everybody is transferring their own data, so chances are that the data may get collided. So in that case, whichever node wants to transmit the data can be given a token so that they get to pass it, right? Synchronization helps, that is the checkpoint long transmission. Suppose if you have long amount of bits which are being transmitted, so in that case, suppose the communication is lost in between, again you have reset the communication. So from where you are going to start, that is called as a synchronization. Suppose there is a crash, right? So again when you are recovering, from which checkpoint you have to start, that is called as synchronization. So this all work is the work of the session, responsibility of the session layer. Then comes the transport layer. So transport layer is responsible for any type of end-to-end communication. So what it does is that it takes the data from the session layer, it breaks into small parts, okay, because the data is a huge, you might have a huge media file, video file, or long email text, okay. So this whole data is broken into small parts called as segments, and then transport layer sends these segments to the network layer. So receiving device, see at the one end, when the sender is there, sender is receiving the data from the session layer to the transport layer. But when it is on the receiver end, it is going in the opposite direction. So the receiver is assembling those segments, right? So the transport layer is also responsible for flow control, okay, so that to ensure that the sender is not very faster, and error control, that the data received is complete, okay. And the transport layer has two major protocols, that is the transmission control protocol and the user datagram protocol, TCP and UDP, right? These are the two protocols helping in transporting the packets. Then comes the network layer. So network layer is facilitating the data transfer. See, network and transport layer both work hand in hand, right? So the network layer, those segments which are being created by the transport layer, they are further broken down into small packets, okay. So these packets are small packets which are sent to the device, receiving device. Receiving device will again reassemble the packets, right? So the network layer will divide the data into small packets and then find out the best path, okay, because sender and receiver may not be a point-to-point communication. They are far from each other. They have to go via various routers, right? So which path is best suitable, that is to be determined. So that is the work of the network layer, and this process of finding the path is called as routing, okay. Then if there is a heavy traffic in the network, it may lead to congestion. So how to handle the congestion, that is the responsibility of the network layer, and it also handles issues related to delay, why the delay is there, why transit time less, why jitter is there. So these all work is the responsibility of the network layer. So what are the popular protocols of the network layer? They are the internet protocol, ICMP, that is the internet control message protocol. It gives appropriate message, what happened, right? Internet group message protocol and IPsec suite. So these are the different protocols of the network layer. Then comes your data link layer. So this helps in facilitating actually the data transfer between the two devices. So main task is to transform the raw transmission into a line that appears free of undetected errors. Okay, there should not be any error. So the sender will break up those packets which has received by the network layer. They are further broken down into small frames. Okay, so the frame size is almost 100 or a few thousand bytes. That's it, not more than that. And these frames are transmitted one by one. So multiple frames form a packet, multiple packets form a segment, and when the segments are combined, they form your data, right? So if the service is reliable, the receiver confirms the receipt and sending back. So you have different types of services here: connection oriented, connectionless. Okay, so if it is a reliable, then when the receiver receives your packet, it will send an acknowledgement saying I received your packet, right? And the last layer is the physical layer. So the physical layer is involved in the bit stream. So whatever frames has been received is created by the network layer, data link layer, is broken down into bit stream in the stream of zeros and ones. So these zeros and ones actually travel through your cable. Understood? So this is how it works. So this is how this is the sender computer. Let's say for example, this is your sender computer, and this is your receiver computer, right? So sender is used, they are connected via the internet. So obviously this OSI layer follows. Now they want to communicate. So the application is written, one mail is written by the sender. That mail is done proper, presented, translated, compressed, encrypted, everything is done. Then it goes to the session layer where it establishes a session with the other network and start the data transfer. The data goes to the transport layer where it is broken into small segments and it takes control. The TCP and UDP connection oriented and connectionless protocol, they control the data. Then the net transport, from the transport layer it goes to the network layer where the segments are broken down into packets, plus it is going to find the best possible route how to go to this destination, that is using routing protocol. Then if there is a congestion, network layer will handle your congestion. Then the frames go to the data link layer where they are further broken into segments, right? Now data link layer will check for some errors if there are any, and flow control. Flow control means what? If the sender is very high speed, it is sending all the messages but receiver is unable to receive at the time, then it is not proper. So the sender and receiver the balance should be proper, right? And then it goes to the physical layer where these frames are broken into bit stream. So physical layer using data cable or using your wireless technology, the data is transmitted as streams of zeros and ones. Now when the data reaches to the physical layer, they are assembled to form small frames in the data link layer. So the errors are checked if there is some error in the data or not, right? Some bits have been removed or not. Signal encoding is done here. Then from the data link layer you go to the network layer. Signal encoding is done in this physical layer. Okay, that analog signal, digital signal when the data is transmitted. Okay, and in the when it goes from the data link layer to the network layer, those frames are again reassembled to form packets. Then it goes to the transport layer. Packets are reassembled to make the segments. Then it goes to the session layer. Session expired. Then it goes to the presentation layer to see which type of encryption is done so that they can decrypt the message, which algorithm for compression is used so that they can decompress the message, and then the data is given to the application layer in a proper format which is being read by the receiver. So this is how these two communicate with each other. So I hope you understood the OSI layers. So keep an eye on my video. In the further video, I am going to cover the TCP layers, and then we are going to discuss the protocols of each of these layers in detail. Don't forget to like, share and subscribe to CSE Core Concepts. Thank you.